Hello students, today we'll talk about the telome theory. This is the last topic of your unit 5. First of all, telome theory. So it was a theory that was given by Zimmerman in 1930. He was the first one to give this telome theory. Now, why telome theory was proposed by Zimmerman? Just because he wanted to explain that how these pteridophytes have evolved themselves from the primitive land plants. And here, when we are talking about the primitive land plant, it includes here the Devonian xylophytales, that is your Rhynia, Horneophyton, Xylophyton, Estrozylon. So how these plants, these pteridophytes have evolved from these plants, these Devonian xylophytales. So first of all, you should know what are telomes basically. Okay. Now in this topic, what we are dealing with, we are going to talk about the introduction to the telome. What is the meaning of the telome theory? How this telome formation, you can say, what is the process that has been discussed in telome theory? Then what are the merits and the demerits? For merits and demerits, I'll upload one PDF also. Go through that PDF, find out some good points and write it down also. Okay. Yeah. Now moving towards the introduction. So it was, I have already mentioned, it was Walter Zimmerman in 1930 who gave this telome theory. Okay. Now this theory is based on the steps in the evolution of vascular plant, how these vascular plants have evolved. So these are the steps that have been explained in the telome theory. Now according to this theory, all the vascular plants, whether they have evolved directly or indirectly, but they all have evolved from Rhynia type ancestral form. Okay, due to the formation of some fertile axis and some sterile axes. Now what is a telome? How will you define a telome? So telome is, it is a simple ultimate terminal portion of a dichotomous branched axis. Okay, that means it is the ultimate portion of a, suppose this is a branch, it is showing dichotomy. So the terminal axis of a branch is known as a telome. It is the ultimate terminal portion of a dichotomously branched axis. Okay. Now these axes are undifferentiated. You cannot differentiate between the two axes. You cannot differentiate. And a single nerve. That means the vascular supply running from here will run here also and here also. Okay. Now, when we are talking about the telome, it could be also a telome, it could be also a telome. Now, which one will behave as the telome, as a fertile one or a sterile one, will depend on the formation of the sporangia. Okay. If the telome are without sporangia, okay, they are called as phylloids. Remember this. Sterile ones are also called as phylloids. Go through the books also. They are known as phylloids. Okay. And if they are fertile one, then they are simply called as fertile sporangia. Okay. Now the point. Okay, I'll explain through the diagram. Okay, here you can see everything is clear. Now see, these are the telomes. You can see these are the telomes, you know? These are the telomes. The point up to where there is no dichotomy, that means the dichotomous branching are united, it is called as mesosome. So this basically, this point will be called as mesosome, because here also you can see the dichotomy is also occurring now. So this is the mesosome. So suppose this is a plant. Okay, now from here the dichotomy has arisen. Now this portion will be known as mesosome. This is the mesosome. These are the telomes. Okay, these are the telomes. Now if the telome is having an sporangia, it is called as fertile telome. If it is not having an sporangia, it is a sterile telome, or you can say another term is a phylloids. Okay, these are the phylloids. Now during the course of evolution, it was noticed that telome became grouped together. They were grouped together. Now these telomes that are grouped in group condition, they are called as syn. Syn means group, and then we have telome, syntelome. They are known as syntelome. Okay. Or another term that we have used is telome truce. Truce means group. Yeah, like we have the truce of the army. There are some bunch of army. So telome truce. Okay. Now a syntelome is called phyloid truce. When will it be called as the phyloid one? When will be a sterile one? See how many terminologies we have read. First of all, we read about what are mesomes. Mesomes are basically the united part of the dichotomous branching. Suppose a dichotomous branching is taking place, then the united part are called as the mesomes. Okay. Now the dichotomy, the terminal part of the dichotomous branching is called as telomes. Now depending whether the telome will have a sporangia or not. If it is having a sporangia, it is a fertile telome. If it does not have the sporangia, then it is sterile telome, or another term is phyloids. Okay. Now it has been noticed that these telomes, they group together themselves. They are going to group themselves. If they are in the form of a group, then we have a term syntelome or telome truce. And if that group it is having the sporangia, then it is phyloid truce. And if it does not if does not have the sporangia, then it is phyloid truce. And if it has a sporangia, then it is fertile truce. Okay. And if both the conditions are present together, then it is called as mixed telome truce or mixed syntelome. Okay. Now talking about the process of telome theory. So Zimmerman said that it is an elementary process, okay, that occurs due to these points. Like first is overtopping, then planation, and then we have syngenesis, then we have reduction, and then we have curvation. Okay. Now, he considered that Rhinia were the most primitive type, and from the Rhinia only these evolutionary process took place, due to which the new type of structures arose. Some will form the leaf, some will form the stem, and some other structures. Okay, so the first point is overtopping. Okay, now here you can see, you can read it overall. Overtopping, it simply means, see, from here the dichotomizing axis developed. There are two dichotomous branching. Now one is going, suppose this one is going to overtop, that means it will be more stronger. Okay, this axis which is very larger, stronger, it will grow very fastly, acting as an main axis. And the other one that will remain weaker branch, it will be overtopped. See, this branching is overtopping this one. Okay, now this remains as such, and that is why this is going to form the lateral structures, okay, like megaphylls. So this is how overtopping simply means that the stronger branch will overtop the weaker branch. It is going to overtake its function. It will start growing as the main axis. Now what happens, it resulted in the development of monopodial system of branching. If you remember, when we were studying about the general characters of pterophytes, we talked about that monopodial branching take place in pterophytes. So this is how monopodial branching arised from the equal dichotomy. Okay, now the second point is your planation. So in planation, it was considered that the equal dichotomies of a system which were in more than one plane came to lie in a single plane. See what happened, suppose there were so many dichotomous branching that kept on overtopping each other, and once they came all in the same plane, there were so many different plants. Okay, so all of them came in a single plane. This process known as planation, and it helps in the interpretation of how the bilateral symmetry has developed in organ from the radial symmetry. It's a very simple process. What happened in overtopping, one stronger branch has overtopped the weaker branch, and it has started acting as the main branch, while the later one, the shorter or the weaker one, it has started acting as a precursor for the megaphylls. Okay, this is how it was suggested that in pteridophytes monopodal branching of system arose. Now, second was your planation. What happened? Several branches were overtopping the overtop. Now, at some point, what will happen? The branches that are acting as the main axis, they are going to lie in a single plane. Okay, when they are lying in the single plane, then uh, they are going to called as the sorry, when they are in the different plane, then they are called as cruciate dichotomy basically. Now when they are going to lie in the single plane, then they form some fan shaped dichotomy. They are going to form some fan shaped dichotomy. Okay, this is known as planation. That means they are going to over see they are going to means, see, you can see here also, here also, they're interacting with each other. Now this is how the radial symmetry changed into a bilateral symmetry due to their planation. That means when they all are lying in the same plane. So it was considered that this planation might have led to the development of the leaf. Okay. Then third is your syngenesis. Syn means grouping. Okay. When there is a fusion due to the grouping. So it is also it was suggested that the mesosomes and telome are fused tangentially. That means, see, these are the mesosomes, these are the mesosomes, these are the telome. They all have fused together. They have fused together. They are lying in a common parenchymatous tissue. They are lying in a common parenchymatous tissues. Okay. Now the syngenesis, it involves the fusion of the vascular bundles also. Okay. Now syngenesis explains why leaves have open dichotomy, pinna, why do they have reticulate venation. This is how these characters have evolved. And what happened? The mesosomes and the telomes, their vascular bundles as well as those structures, they were webbed or they were syngenesis, they were fused. Okay, so that is why they lead to that leaves have open dichotomy, they are pinnatified and they have reticulate venation. First thing. Second, polystylic condition. How this polystylic condition has arisen in Selagina and some other members. How this polystyly arise. So this is explained on the basis of syngenesis. Okay. Now we'll talk about the reduction.